So if you want to watch the live streaming, go to TikTok and look at the TikTok for developers. It's now being live streamed. And my colleagues are working on that. Before we get started, let me see. How many people working on AI or heard of AI? Wow, it's almost everybody. How many people are working on the edge computing? 0? Okay, so today you will have a journey of AI Edge. We're still waiting for the live stream. Did it work? Okay, perfect. Hi. Hello, everyone, and welcome to our collab on the InfiniEdge AI Release 1.0. I'm Tina Zhou, and over the next 10 minutes, I will be introducing you to the platform and highlighted the key updates in this release. Today's session will cover a high-level overview of InfiniEdge AI, along with a recap of the improvement implementations made since the last version. Actually, this is the first version. We did have an internal version. And this will set the stage for the hands-on portion later on. Let's get started. If anybody doesn't have a laptop yet, you can go back to the student dorm to grab one. InfiniEdge AI is our next generation platform designed specifically, specifically for deploying and managing AI applications at the edge. Unlike traditional centralized AI systems, AI brings intelligence closer to where the data is generated, ensuring lower latency and more efficient processing. It leverages modern container technologies or orchestration frameworks to provide a scalable and robust solutions. Additionally, as part of the LF Edge umbrella, it benefits from a strong community and adherence to open standards, which means continuous innovation and support. Let's talk about, oops, you didn't? Oh, okay. Sorry about that. This is a PDF version, okay. Yeah, let's talk about why we build InfiniEdge AI. As AI applications increasingly operate at the edge, developers face unique challenges such as limited resources, like you are using a phone, and real-time the data processing needs, and the complex deployment scenarios. InfiniEdge AI was designed to overcome these hurdles. It not only streamlines the deployment and management of AI models across distributed networks of edge devices, but also offers robust lifecycle management and optimized data pipelines. With enhanced observability and performance monitoring, developers can ensure their applications run reliably and efficiently, no matter the use case, whether it's IoT, real-time analytics, or other demanding environments. Now, let's dive into what's new in Release 1.0. First, we've enhanced our edge node orchestrations capabilities, making it easier to scale and manage the resources across a distributed network. Next, our advanced model lifecycle management introduced improved versioning and smoother deployment processes, including reliable rollback features. The data pipeline has also been streamlined, which means you will experience faster data injections and processing. We've added new observability tools that allow for real-time monitoring and the diagnostics. So you can quickly identify and resolve issues. Finally, user experience improvements and enhanced security measurements and measures ensure that the platform is not only powerful, but also user-friendly for security and more secure. To recap the key changes from our previous version, we moved away from our legacy orchestration system to a more robust and scalable solution that better supports distributed edge deployments. Our lifecycle management for AI models has been significantly expanded, allowing for smoother updates and quick rollbacks. We've made major strides in improving our data handling, ensuring a faster and more efficient pipelines. The new observability tool provides comprehensive monitoring, which is essential for maintaining performance and troubleshooting issues in real time. Overall, these updates enhance the scalability, security, and usability of InfiniEdge AI, making release 1.0 is a substantial upgrade for all users. Without further ado, I would like to introduce my colleagues Xintong and Yuchen to give people a more deep dive in the technology. Thank you.
Right. If you cannot hear me, just raise your hand and let me know. I will try to speak loudly and loudly. So good afternoon, everyone. Thank you for this great opportunity to come to San Jose State University and present. So I'm excited to share with you an overview of our Sphere Release 1 introduction. So the Sphere is developed by my colleague Wilson Wang and the Borelli's team, who are now at Southeast University in China. Unfortunately, they are not. Sorry. Unfortunately, they are not able to come here in person, so I will help them to do the presentation. So first of all, allow me to introduce myself. I'm a software engineer on ByteDance Edge platform team, where I have worked for around 4 years. So if you don't know about ByteDance, you must know its product like TikTok, CapCut, Lemonade, right? So have you ever used TikTok? Just raise your hand if you use it. Great. Okay, so our team is responsible for developing and maintaining a global edge computing platform that manages ByteDance self-built edge clusters. So this infrastructure supports various clients, including TikTok video, live streaming, dynamic acceleration, and game. So have you ever heard of CDN or content delivery networking? Okay, great. So I will just briefly introduce what it is and how we work with CDN. So, and edge computing. So the edge computing is to process data closer to the end users instead of sending it to a faraway data center. For example, if you use TikTok and watch videos, the edge servers near you actually store or cache and deliver the video, so it loads faster. So there are some good point of it. The first one is low latency, and second one is less internet traffic. Third one, it has better performance. So now I'm gonna tell you more about my team. So we focus on building an internal edge platform with Kubernetes native interfaces to manage clusters and bare metals server. And our services also include resource management, workload management, layer 4 and layer 7 load balancing, billing, CI/CD, and site reliability engineering, or SRE. So if you can see this picture, this is our whole infrastructure. Currently, we have more than 200 edge clusters all over the world, or actually it's 40 countries and 226 clusters. We have 3 compliance regions, 5 clouds and vendors, and a lot of servers, CPUs, resources, and hundreds of projects and a huge amount of traffic. And then I go to the so Tina just asked a question, how many of you have ever used AI agents like ChatGPT, Llama, Gemini, or DeepSeek? So I have one more question, like how many of you have used more than one AI agent? Oh, that's great. It's fascinating to see how many of you guys have interacted with multiple AI agents. So as we engage with these tools, we often encounter challenges, such as switching between these agents. You know, some agents are good at this part and other agents are good at that other part. And integrating with different agents and managing their performance, because you know it may have issues like timeout or connection issue, something like that, when you're talking to these agents. So this is where Sphere comes into play. So Sphere stands for Scalable and Performant Edge Agent Runtime. Think of it as a platform designed to efficiently manage and run multiple AI agents, ensuring they operate effectively. And as its core, Sphere takes existing agent applications, or you can say multiple agent applications, and transform them into optimized, deployable services and streamline their integration and performance. Sorry. So here the presentation outline. We just covered the overview, and then we'll go, next we'll go to the overview of our Sphere project. And then we're gonna talk about our progress so far, and then the future plans. Finally, I'll ask my colleague Yuchen to show a demo of the how to use Sphere and how it runs. So first, let's go to the system workflow or overview. So as you can see this diagram, we have 2 phases. The first one is the offline, and the second one is online phase. So let's start with the offline phase. And the first step of offline phase is for developers to write some application code. So have you ever write any application code before? Just raise your hand if you. Okay, cool. So the first step of the Sphere is also write some program or coding, but at that time you can use some existing agent framework like LangChain or Llama Index. So does anyone know LangChain or Llama Index? Oh, great. So, but I'm still gonna introduce a little bit about LangChain, which is an open source framework designed to simplify the development of applications that utilize LLM, such as OpenAI's GPT-4. It provides tools and interfaces that allows developers to integrate these powerful models into various applications, or you can see it as an SDK. And as the output of the offline phase, we're gonna build an instance with your application code and all the needed configuration files. So the key technologies here are, we have two. The first one is multi-instance selection. This technology helps us to decide the best way to run and program, whether as a container, like Kubernetes container, or a module, or a standalone process. It depends on the environment that you are running this program. For example, if you are using a Kubernetes environment or a virtual machine or even a bare metal. So the second technology is automatic code generation. This technology is actually transform the application code into an executable form. This includes code changes and transformations that prepare the code for deployment. So basically, the first phase is just writing the code, compile, and build. And then let's go to the online phase. This phase is actually takes the instance we prepared before and deliver it as a live service to user. So the instance we deployed is now running as a workload. At that time, user can connect it with the workload through API gateway. Like I just send a request to the API gateway, and the API gateway forward this request to the workload. And then the workload or the developer wrote code is gonna talk to the Sphere system service and do the AI works. So here are three important parts inside the Sphere system service. The first one is built-in tools. The built-in is actually a predefined LLM prompt by Sphere. So by utilizing these built-in tools, user can reduce the effort required to write effective queries and leading to more accurate and efficient interactions with LLM. So simple to see is like if you wanna open a web page or do something else, the Sphere predefine these actions for you, and then you can just call an SDK to do these kind of operations. And the second part is planning. So the planning refers to the process by which LLMs generate and organize a sequence of actions or steps to achieve a specific goal. For example, if you want to go to Hawaii and you ask GPT-4 to generate a plan for you. So what are the necessary steps? The first one, like booking a flight, reserving hotel, and planning activities, even buying some tickets for your activity. These all steps should be in logical sequence. So this process needs the model's ability to think ahead, consider various factors, and generate a coherent plan to accomplish the desired outcome. And third part is memory. This is the important part of an AI system. So to maintain the context and coherent in the ongoing conversations, the AI agent allows the model to reference earlier part of the dialogue, ensuring that the responses are relevant and correct. For example, if I ask ChatGPT, who is my colleague Yu Chen? Of course, it doesn't know, but if I ask the next question, when was he born? The system uses memory to understand he refers to Yu Chen. But of course, it cannot know when he was born. And here are some key technologies of the online phase. The first one is cloud edge integration. It's actually offloading the workloads or AI agent workloads across cloud clusters, edge devices, and even the end devices. And the second technology is agent-oriented autoscaling, which is a specialized autoscaling mechanism designed for AI agent, similar to Kubernetes container autoscaling, but it's tailored to the unique characteristic for AI, ensuring that the AI agent responds quickly and reliably. So I will talk more about the cloud edge integration because that's what our team are doing. Okay, let's go to the next slide. This is the whole system diagram of the sphere. So our architecture is designed similarly to an operating system and with a clear separation between the user space and the kernel space, or you can call it system space. So let's start from before that, let me explain more. The blue box here are the components we will develop in this and future previews. And the white blocks are external components and contributions that integrate with the sphere. Okay, so let's go to the user space. The first layer are the agentic application support. So we support various agent applications such as ChatDB, RAG applications, and more. So have you ever heard of ChatDB or RAG? No? Never mind. So the ChatDB is a framework that enhances LLM by integrating them with database to serve as its memory. Like I said before, memory is a very important part of the AI. So this integration allows LLM to run complex text more effectively by storing and retrieving these information using structured database queries. For example, ChatDB enables an AI model to generate SQL commands to interact with database and doing operations like inserting, updating, selecting, and deleting. So this approach improved the model's ability to handle tasks that require multi-step and precise information retrieval. Like I said before, if you want to go to Hawaii. And RAG is another kind of application. This is an AI framework that enhances the capability of LLM by integrating them with external information retrieval system. It's or when you are using the LLM, it always returns some wrong answer or fake answer. Have you ever experienced that? So the RAG is to make sure that it's gonna integrate the LLM with external information retrieval system and allow the model to access and utilize up-to-date domain-specific data and make sure that the LLM won't make up some fake content. Okay, so let's go to the second layer, which is agent developing SDKs. It's like including LangChain, Llama Index, OpenAI Swarm, and I introduced it before, so I'm gonna skip this part. But in this part, we also developed our self SDK, which is Sphere User SDK. And the next is Agent Orchestrator, which acts as a compiler-like module that transforms existing code into a deployable hosting instance. And the hosting instance could be a process, a container, WebAssembly module, or a Sphere-specific isolation technique. Oh, sorry. So here is the system space. The top level is the Sphere API. This API provides system call for Sphere and implementations. Currently, we are using gRPC to implement the Sphere API. And then it's the built-in tools. We have like planning modules and memory modules like that. I also introduced before. And also the important part is Cloud Edge integration. Like it includes key modules like API gateway, cluster management, traffic management, network acceleration to support offloading and seamless integration across environment. So my team, like Edge platform team, gonna work on this part. And currently we have a layer 7 ingress. It's gonna be open sourced, probably this or next phase. And it's gonna charge of the traffic management and load balancing on edge clusters. Okay, so now let's go to the second part, progress and completion. So these are all implementations of our first release. There are 4 key achievements. The first is the POC platform. We developed a working demo that has already attracted significant interest, and this POC is based on Golang, and it's a single node worker. So the second one is runtime support. Our platform currently supports Docker and the process-based runtime. The third part, test cases. So a comprehensive set of the test cases ensures the basic functionality of Sphere, and more testing is planned as we move forward. And fourth part is a tool agent. So we provide an agent that performs tasks like sending emails, searching contacts, retrieving time information, and even open a website. And these are the details of our project progress. The first, and it's actually a feature categories breakdown. The first feature is runtime support. So we are now supporting process and container runtime and working on WebAssembly and Kubernetes integration for future release. And second part is operating models. Currently, the local model is fully supported, so Sphere can run entirely on a single machine. And in the future, we're gonna developing features to support multiple machines and the Cloud Edge integration. For the deployment, we have an auto deployment pipeline with the GitHub Actions to support the auto CI/CD. And the last feature, agent service, we are working on several tool agents like planning, memory. Oh, the last one is, let me try to. Okay, the last one is tools. So let's go to the future plan. It's actually for release 2 and beyond. There are several technology enhancements like automatic instance selection and generation, which is actually refining the process for choosing the best runtime environment automatically. And the Cloud Edge collaborative scheduling is to optimizing workload distribution across cloud and edge networks. I can explain it more here. So it's similar to the CDN that when you access an AI agent, you don't need to go to the data center of that agent, but just go to the edge clusters. So it will be faster, have better performance, and lower latency. And the third one is expanded support. We're gonna integrate with Android support, multiple programming language, and improve serialization, deserialization technologies. And we also have collaboration with industries like TikTok teams and other future opportunities with gaming, automobile, and finance industries. Also, we'd like to work with third-party developers to build more tools and drive a collaboration ecosystem. Also, welcome all of your guys to join the program. And now it's demo time. I would like to ask my colleague Yuchen to do a live demo of the functionalities of Sphere. Oh, by the way, do you have any questions so far? No? Then I will ask Yuchen.
Thank you. First, thanks Xintong for this great presentation. So my name is Yuchen. Like Xintong, I'm also a software engineer from Edge Computing Platform. So my focus is really about billing and the data warehouse. So first, billing, right? So cost is almost every team, every company they cares about. So how to come up with a reasonable pricing model? So how to like collect day-to-day users' resource usage, like how many CPUs they use, how many memories they use, how many GPUs they use, and how to support them to do the auditing. That's all billing system cares about, right? Second, about data warehouse. So like as a cloud provider platform, right, we have tons of data generated every day. We have users metadata, we have login data, we have like a clusters data, like how's the CPU utilization rate over there, like how many more capacity we need to add over there. That's all we care about, and how to store this data, how to organize this data, and how to seek the valuable info from this data. That's the data warehouse project. So yeah, if you guys are really interested in building and the data warehouse, we can definitely talk more about it after this demo. So yeah, let's jump into the demo. So like Xintong previously mentioned, we have two modes, right? We have offline mode and we have online mode. So I guess today we are more focused on the offline mode. So yeah, hopefully we can bring the cloud deployment mode on the next release. Yeah, so today's demo, so you don't need to worry about the code except from the demo folder. This is collab.py is all we need to care about today. So have you guys ever used Python or familiar with Python? Yeah, good, nice. Yeah, I would like to like briefly introduce what the code do. So it's really simple. This is the beginning entry of this Py file, right? And basically we just do three things. I want to run three functions. So yeah, let's try the first one, all right? I will explain later. All right, finished. So if we take a look at the first function, so what does it do? So we give him like 4 inputs, right? Agent. And the second part is the prompts.
The size.
Okay. Yeah, so second part is a prompt that I give this agent in human language, right? I say, could you capture the screenshot of everything on screen and save to this path? And then the model we chose here is GPT-4o. So actually we can choose more model. like Llama and I think Anthropic Cloud. We can support that, but today we only have GPT-4 because we only have that subscription. All right, so if you take a look at my desk, you can see the screenshot here, right? Right, this is the screenshot that I just did. So I think this part can be really useful, right? It's kind of like Siri, but more intelligent than Siri. So imagine that you want to find a picture, your parents, like my parents and I, probably like when we were traveling Disneyland, I want to find that picture. I can just tell the Siri to do that, right? I don't have to manually find the picture. So this is I guess this is the first function I want to show. And the second one is I ask the GPT to help me open the SGS user homepage. Let's try that. Wait for it. Yeah, it opens, right? Have you guys watched the video that Anthropic Cloud guys just showed, like, I think, like 1 month ago? Like he just told the browser, the Chrome browser to write the code, right? Yeah, I think this is the starting point of it, right? We give the agent the prompts and tell him to do the browser stuff. Yeah, last part I think I want to show is this one. So I tell the agent to help me display a HTML page with a button to say hello. Let's see what's the output. Yeah, we have a HTML page with the say hello button on that, and it's actually stored in your own laptop. Yeah, in case some guys may doubt that, oh, you just probably just hard code it. So of course we can change the prompt if you want. Yeah, I will change here, like help me to display a HTML page to thank everyone for attending this meeting and see what's the output. All right. Right. It's cool. Yeah, I guess this is the demo part. And the next, Xinhong and I will walk you guys through the step-by-step, like how to set up the agent on your own laptop. So before that, have you guys have any questions about the demo or the presentation before? Yes. Yes, that's a great question. So actually we have two tools, right? One is a built-in tools. So we've already defined those functions. And the second one is internal tools. So you have to like write your own function to tell the agent what to do. Yeah, it's basically like a car. Like car has some built-in features like headlights, right? Like CarPlay. If you want add something else like rack on top of your car, that's the internal tools. Yeah. Make sense? Cool. Any other questions? All right. I think we can jump right into the tutorial, hands-on tutorial. Yeah, first I want to make sure you guys have this installed on your own laptop. It's basically just a Python, Git, Docker, and a code ID. Personally, I prefer VS Code.
Can it automate the things like for the given credentials? Can it add up the courses?
Say that again.
It opened as they supposed it. Yes. Or can it also add courses for the and one? Add courses. Yeah. Courses. What's the destination? For me, I want here to do courses. If I give from that's a more complicated concept, but we can try. I don't know. Probably. The system can ask that to shut down the shut down your system in your laptop. Let's see whether we have the ability feature in the system we can ask.
Yeah, so after you guys install all the stuff in the where's that previous slide, this slide, then we can start the steps to run this agent on your own laptop. Do you guys want to take a picture of the prerequisites here? Yeah, and also if you guys curious about what like TikTok engineers day-to-day work, feel free to come to us. Or curious about what's the edge computing platform that we're doing. Yes. All right. Okay. Yeah, please raise your hand if you have any questions or problems you encounter during the setup.